Audio Jungle. Audio Jungle.
Now check, this is the problem, and one more problem based on the horizontal turning. So how you may know this is horizontal turning or vertical turning? So that first lecture I explained two types of turning, horizontal and vertical turning. In case of horizontal turning, altitude will be constant. So this is the gate problem. Okay, this is the gate problem, and the problem is, what is the problem? The load factor. The load factor of an aircraft turning at a constant altitude is to the coefficient of lift the coefficient of lift required for turning flight is compared to compared to level flight at the same speed will be. Option they have given here: A, B, C, and D. Four options they have given to us. What is that? Same, half, double, or it's a four time. Okay, this is the problem. Gate problem. You can check the year. Okay. Now, so if you check in this problem, they have mentioned the load factor of an aircraft turning at constant altitude. Constant altitude means it is the horizontal turning, and load factor they have given to us 2. The coefficient of lift means CL they are saying required for the turning flight is compared to level. So two conditions we have. One, that aircraft is what on steady state level. So if it is a steady state level, so definitely this will be the weight and this will be the lift. And steady state level lift, I told you it is L naught. Yes, fine. Now in second case, that aircraft is what turned. If the aircraft is what turned like this, this is the aircraft when it is turned. Okay, then that time this derivation and all you know. Now I'm not going for any derivation because this is simple question only. Okay. But I told you one thing. When the aircraft is at steady state, this is the steady state condition, steady and level flight. So I explained lift will be L naught, drag will be D naught, thrust will be T naught, velocity will be V naught, power required will be P naught. And when the aircraft is what turning, this is the turning flight. Okay. So that time I told lift will be L, drag will be D, thrust will be T, velocity will be V, power required will be P. Yes or no? This is the condition, this is the parameters for the what it is called steady state level and turning flight. And I had given one very beautiful relation between the steady state level and turning flight. What was that? If you remember, it was load factor N is equal to L upon L naught is equal to D upon D naught is equal to T upon T naught is equal to V upon V naught square is equal to P upon P naught 2 by 3. Yes. And this N was load factor and it was sec phi. Okay. This was the relation if you remember. Now they are asking relation between the lift coefficient. So where you will get where you will get lift coefficient. So you have to relate this part. Then you will get the relation between lift coefficient. Yes or no? You can say sec phi, which is nothing but load factor. It will be because velocity, they said here in the problem itself, they have mentioned clearly. Speed is what constant, same speed. Speed is not going to change. If you write the formula half rho v square s into CL divide by 1 by 2 rho v naught square s into CL. I can say this is what CL naught for because they are asking the lift coefficient ratio, so different. Na? So L is nothing but half rho v square SCL, half rho v naught square SCL naught. Clearly they have mentioned v is equal to what? They said velocity is what? Constant. They said like that. Huh? Then that time don't say v is equal to v naught, so n becomes 1. No, n they have given to you. What they have given to you? That load factor it is given 2, I think. Load factor they have given to us, which is nothing but 2. Okay, fine. But speed is constant, so this is the thing. Now what you will get, because density will be constant if altitude, because they have said constant altitude. If constant altitude means density will also be constant. Rho is equal to rho naught. Yes or no? That will be also constant. Definitely area S will be constant. So what you will get? You will get CL upon CL naught. Okay. Now they are asking what is the uh, lift coefficient required for the turning, means they are asking CL. So what will be the CL? CL will be N times CL naught. So what is the CL? N is nothing but 2. So 2 times of CL naught means if steady level lift coefficient is CL naught, so turning lift coefficient will be 2 times of the CL naught, means double. Yes or no? It becomes double 2 times. Yes or no? Check. Because what is the CL naught? CL naught is the lift coefficient during steady level and CL is the lift coefficient during turning CL, and this is the steady and level CL. Okay, that is CL naught. Understood? So you got the relation. So double they have given option. So this is the correct answer. I hope you understood this. Yes or no? Say yes or no. Fine. Now check. Right. So this is the answer and this is the solution I have given to you. So for that reason, I told you that day. This is very special formula. Okay, based on this gate question they are asking many times. So one problem I had solved based on this formula, and it was a lengthy problem, but all the values, all the parameters we had calculated for that particular problem. So I will suggest you please practice numerical whatever I am solving here, and that numerical is what useful for your get problems, okay, because it is like a standard pattern. Whatever I'm solving, it is a standard pattern. Maybe it is asked in exam, or it is similar kind of question. What type of question they are asking in exam? The similar kind of question I'm solving in that class also. Okay, fine. Now as I mentioned, two types of turning. Okay, two types of turning I explain. Two types of turning, which is called horizontal turning. It is also called coordinated turning. Okay, fine. And here altitude will be constant, right? Second turning was vertical turning, which is also called pull up and pull down. Okay, and in this case altitude will not be constant. So basically from 4 5 lectures, last 4 5 lectures, if you check, this part is what covered. Now we are going to see this vertical turning, which is also called pull up or pull down. Okay, pull up, pull down. Now fine. So all right, now vertical plane. So if it is vertical plane, then it means it is the question based on pull up or pull down, based on a vertical turning, which is based on pull up or pull down. So we'll start this new topic, which is called pull up and pull down, which is nothing but the part of vertical turning. Remember here altitude will be changing. Okay, that will not be constant. So what do you mean by pull up and pull down? Simple. Pull up and pull down. So as the word only you can understand pull up and pull down. Yes or no? By the word only you can understand pull up and pull down. So it is just uh, the case when that aircraft is what going to gain the altitude, then it will be the pull up condition. Pull down is just like when altitude is what going to lose, or it is that altitude is what going to decrease. If altitude is what increasing, then it is pull up. If altitude is what decreasing, then it will be called as a pull down case. Okay. In one case, altitude is what gaining. Another case, altitude is what losing. If it is lost the altitude, then it will be called pull down. And if it is gain the altitude, then it will be called pull up. Hope you understood this. There should not be any kind of confusion about pull up and pull down. It's simple only. Very simple. Yes or no? I will give the diagram so it will be more clear to you. All right. Now check. So pull up and pull down. And this side we have pull down. Pull up and pull down. Now, in gym and all also you have seen that exercise pull up. So pull up means what? You are going to gain the altitude. So your body will go up. Called pull up. Pull down, your body is what going down. So pull down, similar kind of. So pull up means simply you need to understand it is the gaining altitude. Pull down means it is losing the altitude. That's all. All right. And that in both cases, what is the common thing happening? That altitude is what not constant in both cases. It is pull up or pull down in both cases. Doesn't matter it is pull up or pull down in both cases. What is happening? That altitude is what not constant. I mean, in one it is going to increase, pull up, and in another it is going to decrease. Simple. Yes or no? So pull up. Suppose this is the center point and it is like a circle here. Okay. And similarly here also we have a circle like this about some center point, just like a horizontal turning you had seen. It was about one center. Yes or no? Horizontal turning, I told you, turning process is like a one kind of the circular motion. That's the reason we had taken centrifugal force. So this is the pull up. In pull up, what is going to happen? In this pull up, that aircraft is what going to gain the altitude. This is the aircraft here. Okay. This is the problem. I mean, this is the diagram. By this way, you can. This is the pull up. That altitude is what gaining. What is the pull down? In pull down, I told you that aircraft is what going downside, means it is going to lose the altitudes. Yes or no? So that aircraft is what here. This is the aircraft, and aircraft is what going like this. Hope you understood this diagram. So this is the pull down. It is going to now altitude is what losing. Now by the diagram is what not so clear. You can understand by this way. This is the center point. This is the center point O. All right, pull up, pull down. So this is the way to understand pull up and pull down. So one by one, first I will take pull up. We'll give that small, very simple derivation, nothing to worry. Very simple derivation. Okay. Now check. So we'll go for the pull up first. Pull up. Okay. So in this pull up condition, we can say this is the aircraft condition. Okay. And aircraft is what going up. Like Sorry, the problem in diagram I'm not good actually. That aircraft is not going in this way. Okay, fine. Hope you understood this. Now, so I will show that forces in this condition. What will be the force? The force I can show you in the pull-up case will have a radial force, okay? Because it is on the vertical plane. Pull up, I must write vertical plane turning, okay? So in this case, obviously, whatever the weight you may have, that weight will be acting downward. Doesn't mean it is what direction, but gravity force will be always perpendicular downward. All right, but lift will be what? Just because this is the velocity, so perpendicular to velocity, I mean, your lift force will be like this. This will be lift force perpendicular to the direction of the velocity. Direction of velocity is here, so lift force will be perpendicular. You can say like check, this is perpendicular. Hope you understood. Yes or no? Right? Now, so that will be very clear. Whatever the lift here, okay, whatever the lift force, that lift force will be greater than weight. Then only it is going pull up. If it is gaining altitude means what? Lift is greater than weight. If lift is equal to weight, then it is steady level. Yes or no? If this is very clear, if lift is equal to weight, then what is the mean of it? It is not going to climb. If L is equal to W means it is not going to climb. That altitude will be constant in this case because that vertical force is equal to, I mean, vertical upward is equal to vertical downward. So force is what balanced. It means altitude is what not gaining. Altitude is what constant. That's the reason it is called as a cruise flight. Cruise condition, which is nothing but steady state level. Steady and level flight. Yes or no? But this is what just like a climbing flight. No? In climbing, what will happening? It is the gaining altitude. So similar kind of this. Okay, pull up. So this is the very short time. No? Climbing is the long process, but this is not long process. It is just like a pull up. I mean, for the very short time of period, it will go in upward direction. Okay, and then the whole process will be called a climbing. Actually, pull up is just a yeah instantaneous like a process where it will take for very short time of period that aircraft will go. It will turn up in upward direction, and after that it will be climbing. Yes or no? So it means L is greater than W, means lift is greater than weight, then only it is going to gain the altitude. Okay. So if it is gaining altitude, it means L greater than W means altitude increasing. Yes or no? Altitude will not be constant. And then it will be called as a pull up. Okay. Hope you understood this. Now, so in this situation, what will be the force? Lift force, it will be greater than, lift will be greater than weight. Okay, and if you check the from any distance, you can check this is the nothing but here, this is the R. Okay? This is the R, which is nothing but radius of the pull up condition, radius of the circle, which is nothing but in pull up condition. R is the radius, or you can say it is radius of turn because it is the turning. Yes or no? So pull up also can called instantaneous turn. What it is called instantaneous? What do you mean by instantaneous? Instantaneous means it is for very short time of period called instantaneous. Okay. Somebody can ask to you what will be the difference between the climbing and the pull up conditions. You can say pull up is the instantaneous turn. For very short time of period, it will change the direction. You can think like, see, like aircraft is what climbing means it is gaining altitude. So earlier it was running on the ground. Okay, I will show you in different diagrams. It will be more clear to you. Suppose this is the horizontal. Okay. Suppose this is the horizontal. Aircraft is what is standing here. Okay. Aircraft is standing here. Yes or no? You can say now aircraft is what is standing here. It was going in a horizontal direction like this, but it will not go continuously. After certain distance, that aircraft will be going like this, and then it will have instantaneous turn like this. Yes or no? Instantaneous turn in upward direction. I'm just giving the one example, but it is happening in turning. It is not exactly like this what I'm explaining. It is like I'm just showing what is the mean of instantaneous. So that aircraft will be going like this only. Okay. And it will be like this. So this is called instantaneous turn in vertical direction like this. And after this whole process will be called as a climbing. This will be called as a climbing. It is climbing only. It is climbing only. Okay. It is climbing only. And then here it will go for the cruise. Hope you understood. So this whole things will be what climbing. But from horizontal to this uh, climbing from horizontal motion of the aircraft means it was going like this, and now this is the climbing. Okay, so this short time of period or instantaneous turn in upward direction or in pull up condition is nothing but pull up or instantaneous turn. So this will happen in vertical in the flight condition when it even it is flying at some altitude also, not always on ground. I'm explaining for the ground so that you can feel like okay, first aircraft will run horizontally, run on runway, and then it will climb. So you can feel that, but it will be happening at any altitude, 3 kilometer, 4 kilometer, 5 kilometers, when aircraft uh, will gain the altitude. So how it will gain? It will go in upward direction. So that instantaneous turn in upward direction in vertical plane will be called as a pull up. I hope you understood this explanation. Okay, fine. So now we are going to derive for the pull up condition. Here we are seeing the pull up. So in pull up, I have shown you that the force balancing for the aircraft. This is the aircraft here. Okay, this is the basically arc where the aircraft is what going to uh, pull up. So I must draw another color so it will be more clear. Mhm. Okay. Now you can say this is the circle from where you are uh, considering that aircraft is what going to turn. So this arc will have a radius from the center R. Okay. I told you that weight will be acting in downward direction. Definitely. Here, this is the velocity of the aircraft. So perpendicular to this velocity will have a lift force. So you can say this is the lift. Please can correct this diagram. So this is the lift force in upward direction, so this lift will be greater than to the weight. All right, this is the pull up. Now so in this case, that force, if you check resultant force, so resultant force you may have Fr, which will be okay, because whatever the angle you may have here, whatever the angle you may have, and how that angle will be measured, you can measure this angle. So this angle is what? Theta, and this theta is very small. This theta will be very small, because if you check, so this will be the theta. Okay, so whatever the value of L cos theta will be weight. Okay, this theta is what? Very small. All right, so L, you can say approximate to weight, but I told you if L become weight, lift is equal to weight, then it will be steady state level. So that lift exactly will not be equal to weight, but L lift will be greater than greater than to the weight. So if I write the resultant force Fr in upward direction, so L is greater than to the weight, so I can write L minus W. That will be the resultant force in upward direction. Okay, yes or no? Now, now this force will be equal to the centrifugal force, because towards the center, this is Fr is the towards that center, towards center. So away from the center, we'll have a one more force called mv square by r, which is nothing but away from center, and it is called centrifugal force. Centrifugal force. So for the balancing condition, what you can write? You can write that Fr, which is nothing but mv square by r. All right, mv square by r. That's the mean of it. Now, now, if you check, Fr is nothing but lift. How you can write this? What is the load factor N? So load factor N, definitely it will be lift by weight, and that will be greater than 1. In turning, I told you, in turning flight, load factor will be greater than 1. So this is nothing but, what is the L? L will be N times weight. This is the lift force. One more you can, that otherwise there will be a confusion all time, that component, because it was a very small angle. So for that reason I have, you can say this is nothing but, if you check this line, if this is the theta, so better you can say along the lift force, so that will be more clear. uh, okay, here I will show you it, because it is a small angle, but still it is small, but that component should be correct. I mean, because along the, this is the center. Okay, this is the center here, so along the center, if you draw the line like this. Okay, so this will be m v square by r, and here this will be FR. Okay, you can say because this is theta, so this will also be theta. Yes or no? Here you can say this is W, so this will be W cos theta. Now better, no? So you can say L is W cos theta because lift will be in this direction. This is the lift. Yeah? So because theta is very small, so cos theta will be what? Approximate to 1. But is exactly, I must say that theta will not be 0. So you cannot say cos 0 is 1. So whatever the resultant you may get, FR, that will be L minus W cos theta. But that theta is very small, so cos theta become 1, you can say. For that reason, FR you will have L minus W. So this should be very clear. In short, I thought you may understand. For that reason, I skip that part. So now you can say FR is L minus W. So along the radius, this resultant force you are writing along the radius of circle or along the radius of front. What you have written? Resultant FR is equal to L minus W mv square by R. What is the L? Lift force. Okay, and L by W will be load factor. So what is L? L is NW. You write, so F R you have L minus W. This you can write L is equal to what? NW minus W. Here you can write, okay, W in bracket N minus 1 is equal to mv square by R. This W N minus 1, M is as usual mass of the aircraft. Okay, R is the radius of turn, V is the velocity of the aircraft. There should not be confusion. Everything is what same. So what will be the mm cancel out? R. R is nothing but this is the formula. Okay. If, if you check what is the radius of turn, radius of turn in which case pull up, then R is equal to V square by, okay. This is the formula you need to remember. And it's simple one. It is the simple one. There should not be any confusion. Okay. R. Radius of turn is nothing but R. Rest everything same. What is N? Load factor. What is V? Speed of aircraft. As usual, nothing is changed. Yes or no? Everything will be the same thing. All right. Fine. Now you can say this is the radius of turn. So similarly, you can write the rate of turn also or turn rate. So here you can give the heading turn rate or rate of turn, which is nothing but omega. V is equal to R omega. So what is omega? V by R. V R is nothing but what? V square upon G n minus 1. If you solve this, then what you may get? You may get divide by V. Yes or no? So what is the turn rate? Turn rate is nothing but omega. It is nothing but, okay, where is the speed of the aircraft. All right, there should not be any confusion about it. Yes. Now, fine. This was the formula for the pull-up condition. Okay. So here, because most of time confusion about the FR, so clearly in short, in one side I have explained this, so it should be very clear to you. Earlier component what I had taken, it was not correct. L cos phi I had taken. If you take L cos phi, then load factor will be less than 1. But in turning, no, load factor will be greater than 1. For that reason, I had changed the component. I had taken along the radius, so this W cos phi is equal to L. Now it is fine. Okay. So this is the value. Anyway, now if you check this, this is for the pull up. We'll go for the similar thing we have to do for the pull down case. So we'll give heading pull down. This is again, I told you this is the instantaneous turning. Sometimes it is called maneuvering, instantaneous turning, or also called maneuvering. What it is called? Instant. I told you this instantaneous means for very short time of period. So this pull up and pull down, it is for very short time. Like when it is going to gain the altitude, so for very short time of period, it will go pull up. Then next part will be called the climbing, because climbing means what directly mean it gaining altitude. So instantaneous turning, or which is also called maneuver. Okay, that is nothing but maneuver. What it is called? Maneuver. Yes or no? Maneuver. Maneuver. Okay. In the vertical plane, because maneuvering is what both horizontal plane as well as vertical plane. So this maneuvering in vertical plane will be called a pull down. So we can draw the diagram for the pull down also. Yes or no? This is the circle part. Okay. That aircraft is not going to turn like this vertically. Huh? So if you draw the diagram, so you can easily relate. Huh? Fine. Okay. Draw correctly. Huh? Fine. Now this is the aircraft. It is going downside. So here you can say this is the center point. This is the center point. You can say this is O. From any distance, you can take radial distance. This will be the R. Okay. Radial distance R. Now if you check here for the pull down case, where will be the weight? Weight will be acting downward. Weight will be acting downward. Okay. And at the same time, because the aircraft it is going pull down, so if you check the, because it is like a inverted flight. What is this? Inverted flight. In like it happens for the fighter aircraft, not for passenger aircraft. That air show and all you have seen might be in Bangalore. So it is like inverted flight. That aircraft is what reached to peak point and it is going to dive. This is also the diving of the aircraft. So what will be the lift? That time lift will also be in downward direction. Yes or no? Because if you check at for instantaneous means for very short time of period, if time period is zero, then whatever the theta will be zero. Here also you can mention because it is the instantaneous. Okay, so instantaneous means for very short time of period. So for very short time of period, at instantaneous means for time period is equal to zero. When time t is zero, then that time theta will be zero. Okay, that time only if theta is equal to zero, that time only this will be what? Fr will be L minus W. Okay, so that is very simple point. Now, so in that case also, if you check the component, so it will be like L plus W cos theta. Okay, if you write the component, so because it is theta for instantaneous time, theta will be 0, so cos 0 will be 1. So whatever the resultant force you may have, okay, what will be the resultant force you may have, that will be uh, Fr Fr, no? It is L plus W. Okay, that cos component will be 1 because cos 0 will be 1. Okay, cos component will be 1. So exactly it is going to get down both lift and weight. So again you will like in radial direction. Radial direction means in this downward direction. If you equate the force, Fr will be towards the center. Okay, and away the center will be the centrifugal, which will be mv square by r. This will be what? Towards the center, towards center, and this will be away from center. Yes or no? So it will be balanced. Yes or no? So total force in radial direction is equal to 0. Okay. So you got L plus W is equal to mv square by r. As you know, N is equal to what? Lift by weight. So what is lift? It is nothing but N into weight. You can write this. So you can write W is nothing but mv square by r. So cancel out. What you will get? R. This is the radius of this is the radius of turn in which case? Pull down. Right? Radius of turn pull down. Yes or no? Now we'll write the rate of turn. Rate of turn. What is the rate of turn? It is omega. So as usual, This is the rate of turn. Yes or no? Rate of turn for the pull down case. Rate of turn for the pull down. All right. So the whole thing now, summary you can write. Summary you can write turning. Turning flight. Horizontal turning. Vertical turning. Okay. In horizontal turning, what was the radius of turn? It was v square by g in root n square minus 1. Yes or no? This was the radius of turn. But in vertical turning, we have two things again called pull up and pull down. So for the pull up, radius of turn will be v square upon gn minus 1. For pull down, v square upon gn plus 1. Okay. This is the summary because now turning flight I am going to close here because it is like a 4-5 lectures I have covered. 5 lectures I have covered, I think 5 or 6 lectures. Anyway, it doesn't matter 5 or 6. The thing is, it should be covered completely. So, second is rate of turn. Okay, what is the rate of turn for the horizontal? Rate of turn is nothing but uh, g n square minus 1 divided by v. This was the rate of turn for the horizontal, and here for the pull up rate of turn is nothing but pull down, it is nothing but v. Now this topic is got closed here only. It is no all the parts. I have not left anything in that important part in turning. What was important that I have explained well. Okay, theory based numerical also we had solved in last lecture, and numerical obviously you have solved more numerical. I will give some few numericals for the homework also, so you can practice okay by your own. Now we'll see like from the vertical plane, few question they had asked. Okay, so that vertical plane turning or vertical turning based question also we have to solve. Fine. So few question we'll see like that latest question. It was I think 2020 gate 2020. I think it was asked. So let me check that question. So vertical turning based question, it is again that formula you have. If you have the formula, so obviously you can crack that question. There should not be any problem because it's a very basic type of question. Huh? Very basic type of question. There should not be any confusion about it. So this question is gate 2020 for 2 marks. Okay. If you read the sentence only, you can understand this is the vertical turning problem. So question is, an airplane of mass 5000 kg is flying at a constant speed of 360 kilometer per hour. kmph means kilometer per hour. At the bottom of a vertical circle with a radius of 400 meter. Okay, with the radius of 400 meter. Wait, just wait. 400 meter as shown in the figure. As shown in the figure. Okay, assuming that assuming that assuming that acceleration due to gravity acceleration due to gravity okay is 9.8 meter per second square. The load factor the load factor experienced at the center of gravity at the center of gravity of the airplane is okay rounding off round off to two decimal places. So this is the filling problem. Okay, you have to fill by the virtual calculator in exam. You have to fill the data, you have to calculate, and you have fill the number. Okay, remember, till two decimal they will computer will consider the correct answer. So whatever the value you are filling, if you are filling in that range, then only computer will correct your answer, otherwise 0 marks. Remember, for such type of problem there is no negative marks. Okay, there is no negative marks for the fill in the blank question. Like such type of problem is what called fill in the blank. So if you are filling wrong, so you may lose the marks, but you will not get negative marks. Okay, for that. Anyway, so if you solve this problem, what they have said, vertical circle, bottom of a vertical circle. So I will draw the circle. This is the circle, okay? This is the circle here, and in the problem they had said there is a vertical circle. So immediately you need to understand this is the vertical turning, and for the vertical turning, where is the aircraft? Aircraft is what on the bottom of the circle, means somewhere here. Understood? The aircraft is what somewhere here. Hope you understood this. And as usual, because it is going for what? This is the pull-up case or not? This is the case of pull-up. I must write. There should not be any confusion. That aircraft is not going to gain the altitude because it is on bottom. So it will go and it will rise. So means it is going to uh, gain the altitude. Yes or no? Now, if you go for this particular problem, so as usual, like somewhere this is the center point. I must say this is the center point. So definitely two types of the forces because this is the center. So towards the center, resultant force will be acting Fr. What is the Fr? L minus W. How it is L minus W? I told you that the previous explanation I had given. And here, away from the center, what is the force? Mv square by R. Finished. You can mathematically you can balance this. It is nothing but L minus W is equal to mv square by R, or N W minus W mv square by R. So you have to remember the formula. No need to derive every time. Okay. So what will be the n minus 1? Because they are asking load factor. In the problem, what they are asking load factor. So mass is cancel out. It will be v square by R. What will be n? 1 plus, finish. Check. In the problem they had said what is the load factor. See here, clearly they have mentioned what is the load factor. See, na? So velocity they have given 360 kilometer per hour. Mass they have given, I think mass is cancel out, so no need to write it. Radius of the vertical turn 400 meter they have given to you. And G also they have given for safe side 9.8. If they have not given, you can use that. So we'll write this. They have given what value they have given to us? Velocity, which is nothing but how much? 360. No? How much it is given? 360 kilometer per hour. Fine. So yes, we find that 360 kilometer per hour. So okay, fine. Velocity is 100 meter per second. R they have given to us 400 meter, I think. Let me check once. 400 meter. G already they have given. If they have not given also, you can calculate. So find n is equal to 1 plus v is what 100. Calculate this. This is what 100 divided by 400. 100 square divided by 400 divided by 9.8. 1 plus 2.55 is nearby 3.55. No? This is the answer. Yes, this is the answer. So what is the load factor here you got for this problem? N is equal to, so till 2 decimal you have to fix the value, like here 0.55. So they will give the range, okay? They will give the range. In that range only your answer should come, otherwise that computer will not correct your answer. Now check. It was, see here I have written this derivation. If you are not writing, only if you remember the formula only. What formula? Simple. What formula? That radius of turn formula. You just write R is equal to V square divided by C n minus 1. If you know this formula, immediately you write n minus 1 is equal to V square by Rg, or you can write n is equal to 1 plus, finish within 2 minutes, not 2 minutes, less than that. What marks you are getting for this? 2 marks, I think. 2 or 1 marks? 2 marks, I think. Check it. Yes or no? So, problem will be asked to you like this only. 1 marks question, I think. Yes, 1 marks. It was 1 marks question. Let me correct this. So, within second, you can get 1 marks, not 2 marks. Sorry. So, such type of problem will be asked to you. Okay, so be ready for the question what they are asking in exam nowadays. Also they are asking very simple question. I will suggest you till what I have taught you, okay, till now in my performance subject, what I have taught you from the starting, if you check, it was standard atmosphere, okay, then we'll go for the air speed, different type of air speeds, and pitot static tube, pitot tube, okay. Then we had seen that minimum drag, minimum drag, and minimum power required, okay. Then we had seen range, endurance for jet, and propeller engine aircraft. After range and endurance, sorry, we had seen, sorry, climbing flight. Then we have seen gliding flight. Now this is what, turning flight.